A few years ago, a game Townscaper caught my attention. In this game, you just click anywhere on the map and the building appears. You click next to it and it expands. You repeat this, and each time a new piece of building just pops up out of nowhere and perfectly connects to an existing piece of building. So recently I decided to work a bit on replicating this mechanic. Of course, I couldn't just fully copy Townscaper, so I need to add some twist to make it more unique and not violate any copyright laws, because you know those exist. So, after years of work, I present to you the Blindscaper. It's basically like Townscaper if you lost your vision. The Blindscaper has thousands of different models and decorations, way more than Townscaper. It truly allows you to create anything you could ever want to create if you were blind. If you want to make it extra spicy, you can even cut off your hands to play in a handicap mode, which makes the game extra hard. This is a joke, this game does not have any accessibility features, so it would be almost impossible to play without hands. Also, cutting off your hands can cause some other minor inconveniences in life. However, you are a grown-up person, so you can do whatever you want. Download now by emailing me at blindscaper@outlook.com. Yeah, the download is being done through email, so if you want, just email me and I will send you the game. I mean, you can trust me, I'm a random stranger on the internet, so I will definitely not send you any kind of viruses. Pinky promise. Okay, that said, creating Blindscaper was actually quite easy, so to challenge myself a bit more, I decided to replicate this mechanic once again by making another game. This time without this blindness mechanic, because I don't really like it. It makes the game way too realistic, you know. Like, the graphics are extremely well done. You can't really separate it from life, and you might think that you actually went blind. So because of that, I decided to remake this game just without the blindness mechanics. To be clear, now I'm not copying Townscaper anymore, now I'm copying Blindscaper, so there's no more copyright violation issues. So, how does Blindscaper achieve this magical building mechanic? According to this random video and basically any other source I could find, it uses wave function collapse algorithm. This algorithm is quite interesting and useful in itself. It can take a few random pieces that connect to each other and then generate a large image or map out of them. This is nice, as you can generate something nice without modeling parts of all possible combinations and their connections. However, I'm not sure if that's that useful in this specific scenario, as in our case, all possible combinations of connections must be covered, as well, player can create whatever we want. There are no rules, we can place tiles anywhere and all of them must be able to connect. However, I kinda liked experimenting with wave function collapse, so maybe one day I'll make a dedicated video about it. For now though, instead I just went with a good old rule engine, because rule engines are easy, sometimes, if I won't fuck up, of course. So the goal here is to create some kind of dynamic placement rules that could be used to generate the entire building using a single array scan. This could be much more efficient and faster when wave function collapse, and if I won't fuck up while designing it, it could even be simpler to use. Of course, possibility that I won't fuck up is quite low, but hey, let's be optimistic. So after thinking for like 10 minutes, I came up with a design that I'm going to use for my rule engine. So my solution is going to use a hierarchical structure where we just divide stuff going deeper into the structure. So we start with the building at the root, because we are trying to create the building. Then we divide it into tiles, when tiles are divided into quarters, and quarters are divided into parts. To understand what tile is, we have to take a step back. To create our buildings to allow users to place random building pieces anywhere on the map, we use a multidimensional array as the base map. We can imagine that each element of this array takes a certain amount of 3D space. In this project, let's say that each element is a cube, with 2.5 meters dimensions. For those who do not understand metric system, here's a random line for scale. Then we can imagine the entire array as volume of these cubes. In this hierarchical structure, you can think of each cube as a tile that can be a part of the building, or it can just be an outside tile that will not actually form the building. At first, I considered having a structure of only these tiles. The idea of tile is that you can take an element in a multidimensional array, check its value and values around it, and using that decide what 3D model you need to place in this location. We repeat that and eventually we assemble the building using these tiles. However, This approach of using only tiles turned out to require quite a lot of 3D models. Basically because there are just too many possible combinations that each tile must connect to, so yeah, that didn't really work. This hierarchical structure actually addresses this issue because we split tiles into smaller pieces. Building is still being assembled from tiles, however tiles themselves are being assembled from quarters. Quarter, as the name implies, is 1/4 of the tile. Because it only connects to a tile above, tile below, tile in front, and tile at one side, and tile diagonally to this side, and tile diagonally to that side, and okay, you got the idea. There's still quite a lot of tiles to connect to, however, it's way less than it would be if we were to construct the entire tile at the same time, instead of creating parts of it. So this decreases the number of possible combinations needed quite a bit, however, there's still a lot of them. And another issue is that each time you need to add slight variations, like a window here, a lamp there, or something like that. You need to remodel the entire quarter again and again and again, and that's too annoying. So that's where the parts came into play. Instead of modeling quarters, we assemble quarters from the parts. This allows us to decrease the number of models needed by quite a lot. It also allows us to add more small details, like the aforementioned lamp. You can just model lamp, create a rule for it, and boom, it appears here. You don't need to remodel the entire wall with that lamp, then remodel that same wall with lamp and window, and so on and so on. But how do we instruct rule engine where which part can actually be placed? Because, up until now, everything was just theoretical. So, this is where the actual rule part in the rule engine comes in. Rule is defined as a string of 12 characters split into 3 sections separated by underscores. This string is called a quota combination. Each character represents a value of an element in our word array. 0 means that the element is marked as outside, 1 means that the element is marked as inside, meaning that at some point player clicked on that location to place a building in it, and hyphen means that the element is outside of our array bounds. This is useful if we decide to use a different part at the edge of our array. So if we take the following rule and take the middle section from it, the first value will represent the cell where the quarter being assembled is placed. If it's set to 1, the part will be considered for quarters that make up the inside tiles only, and if it's set to 0, the part will be considered only when evaluating quarters that make up outside tiles. We actually don't really evaluate tiles that make up outside at the moment because that's a bit slower and I don't really have any models to place on the outside location, so yeah, theoretically it could work, but practically I have an if statement that skips tiles for outside evaluation. The second, third, and fourth values though represent 3 neighbors that are connected to the current quarter's tile and are on the same floor as the current tile. We have 3 sections like this, each of them represent different floors, the floor above, our current one, and the floor below. Each part must support multiple rules as we do not want to create a separate part for each possible quarter combination where the same model might fit. To achieve this, when defining a part you can add multiple rules to it, and each of these rules can have multiple transformations attached to it. Possible transformations are rotation, flip X, and flip Z. As the name implies, rotation rotates the model by 90 degrees on the Y-axis if the part was matched with this rule. I realize that the name rotate does not really imply all this information, but that's how it works. Flip X basically flips model on the X-axis, and flip Z flips the model on the Z-axis. This is extremely useful as there are a lot of cases where the same part can be used after some combination of these transformations applied, and you don't really need any other transformations because anything else you could think of can be achieved by doing some combination of these 3, except rotating on like X-axis. However, none of the parts I modeled up until now would require anything like that, but maybe in the future it might be needed, so we'll see. Using this rule definition system, we may need to create over 100 rules for each part. This is annoying, and to avoid this, in addition to previously mentioned characters used in our rules, we also have some additional helper characters. One of them is, of course, the wildcard character. Wildcard character basically means that the element value does not really matter. This is useful in situations where the part being placed does not actually do anything to connect with the neighboring cells, so it does not care what values this neighbor holds. As an example, let's take the wall part. It has two parts, one below, one above, that actually do something to connect to the floor above and floor below. However, the wall part itself doesn't really care what is above it or below it, because some other part handles that connection, so we can use wild characters to indicate those locations. And then we have an character, which means that the quota is either outside or out of bounds. This is needed because, as previously mentioned, I separated what it means to be outside of bounds and what it means to be just outside of the building. So yeah, this kind of joins them and solves the problem that I created for basically no reason. With this, each part needs way less rules to cover many different possible placement locations because, well, wildcard character always makes everything easier. And the N character also helps a bit. Not that much, but it helps. So for rules to support variations, we also need to know which parts are equivalent. That is, which parts can replace other parts and not break the model. If we were to simply take a couple of random parts from all parts that match the quotas combination, it likely would not work. If we took all parts that match the quota combination and placed all of them, we would not be able to have variations, as it would cause parts serving the same purpose to be placed, and that would cause overlapping. To solve these issues, the configuration allows creation of layers. Layer is simply a list of parts. Rule engine will place 0 or 1 part from each layer. That is, if no parts from the layer match the quota combination, no part from this layer will be placed. However, if one part matched, it will be placed, and if multiple parts matched, one randomly selected part will be placed from that layer. So we can have a layer for bottoms of the wall pieces that connect to the ground or floor below, a layer for the walls, and a layer for the roofs, and a layer for some additional decorations, maybe even 2 layers for some additional optional decorations. This will guarantee that all the required pieces will be placed, and also that we will get some variations on some additional pieces placed. Each layer also has a usage chance property. If it's set to 1 or higher, the layer will always be used. Otherwise, it sometimes will be skipped, sometimes it will be used. It's random. This is useful as we may not want to always place some decoration models. We might want to leave it to a chance, right? This system is nice and all, however, there's one issue. When I need to configure the parts, it is extremely hard to do so, because it's hard to understand if all possible combinations are covered, and if any combinations covered by one part are not accidentally covered by another part, and if they don't overlap, and every time I fixed some of issues I found, I created another one, so my manual approach to this was a bit flawed. It took like hours and hours of work, and I still was able to find random issues. To address this issue, I built this tool for Unity that calculates some statistics. As an example, according to this tool, it's statistically likely that no one would care if you died. Sorry, mixed my statistics tool with a mirror again. Oh, whoopsies. Statistics for the layers. These statistics show multiple things about each layer. What quota combination each part match, including combinations that are matched by multiple parts, what combinations that have current elements set to 1 are not matched at all, and what combinations that have current elements set to 0 are not matched at all. These two are separated, as in many cases we may not want to create parts for combinations of empty cells, mainly because those are not actually evaluated, as I said. And having those in the same list as combinations for inside cells would just clutter the list and would make it harder to notice missing parts. Statistics also include what parts match nothing at all, to know if part is not used, maybe it should be used, or maybe it can just be deleted, and what is matched by the fallback combination. I realized I didn't talk about fallback combination. So fallback combination is just a part that can be placed if nothing else is matched, and the fallback parts rule is matched. So the only difference between a normal and a fallback part is that fallback part is never considered as an option if any other part matches the rule. That's also useful for debugging and not really used for anything else, but hey, maybe it will be used for something in the future. Using these statistics, I was able to define configurations much quicker. By quicker, I mean I was able to define them and not just be stuck in an infinite loop of failure. Just like you. Once all that was done, there was still something to upgrade. There are some cases where simply knowing the neighboring elements may not be enough. For this case, I also needed to add custom rule support. I know it sucks, you create a rule engine and then it doesn't really cover everything, so you need some custom patch on top of it. Then the only thing you can do is create the patch instead of redesigning everything again, because fuck that. This introduces some complexity to the system. However, contrary to the popular belief, complexity is a good thing. You see, if you make all your systems complex, you can then brag to everyone how complex stuff you work with is, and everyone is way more impressed by it. And let's be honest, no one cares about your project enough to actually listen to what you're saying, and so no one will actually question your choices. Custom rules allow you to write your own code that will decide if parts should be placed, and also allows the part to be placed in multiple locations per one evaluation. As an example, we need a custom rule that would place support pillars for building parts that are sticking out. Simple rules cannot achieve this, as we only know about their neighbors, and the parts being supported might be further away. So we can create a custom rule for pillars extension. Once done, the custom rule is automatically detected when creating a part and can be selected in this dropdown. If a custom rule is selected, that is, this dropdown is not set to no custom rule, which is actually also a custom rule, however, it's a special custom rule. But if it's not set to no custom rule, then the regular rules will not be evaluated. Now that we have the core engine working, I decided to release it as a small, simple, pointless game on itch.io. It took quite some time to make all the things that a game should have, like saving, loading, audio controls, etc. And I'm not sure if it was worth it, but hey, you might want to check it out using the link in the description. Or if you prefer more sketchy ways of getting your games, you can email me at blindscaper@outlook.com and specify that you want the Architectopia game instead of Blindscaper, and I will send it to you, and pinky promise, no viruses. Wait, did I mention that the game is called Architectopia? Yeah, Blindscaper was way better. Anyways, I'm planning to continue this project by adding a bit more custom rules, more tiles, maybe even different theme tile set, I don't know. And one day maybe even adding skewing to the grid of buildings to get that more natural and less blocky aesthetic that Townscaper has. Or maybe I'll just drop this project forever because I don't really like modeling, who knows. Anyways, bye.